Hi, everyone, and welcome to SCN8A Unraveled. I'm Sarah Tay with the International SCN8A Alliance, and today I'll be interviewing Jennifer Wong from Emory University. Jen, would you like to introduce yourself?
Thanks, Sarah. I'm Jennifer Wong. I'm an assistant professor in the Department of Human Genetics at Emory University. I work with Dr. Andrew Sky. And so one of the things that we're interested in is studying rare genetic epilepsies like SCN8A epilepsy. And one big thing that we do is making different mouse models to better study epilepsy with the goal of developing better treatments for SCN8A epilepsy.
Well, I am so happy you could join us today to talk about the importance of mouse models. So, to start with, can you talk about what kind of mouse models are used in research?
Sure, there are several different types of mouse models that we use. So here I have the wild type mouse, which is a normal mouse. This mouse doesn't have any mutations. And then when we're thinking about SCN8A epilepsy, we can either knock in mutations or knock out mutations. So we can also make knockout mice. And so knockout mice, so for SCN8A epilepsy, would be like knocking out a part of SCN8A or deleting a part of SCN8A. So if you think about it, this is relevant to loss of function SCN8A mutations, where we've knocked out a part of SCN8A. And then when we're thinking about gain of function SCN8A mutations, many of these mutations we can knock into the mouse, so making knock-in mouse models. And so, for example, we have here the human R1620L mutation that we've knocked into the mouse SCN8A gene. And then finally, we have conditional mice. And so for conditional mice, we can either knock in or knock out the mutation into particular different cell types. And so when we're thinking about SCN8A epilepsy, so in some cases where the mutations are more severe, so like R850Q, it's harder to make a knock-in mouse model of a severe SCN8A mutation. And so we can use a conditional mouse model and knock in the mutation into different cell types and study the mutation that way.
Okay, that makes a lot of sense. So then what can you learn with these mouse models?
So there's a lot of different things that we can learn from mouse models. So one example is that we can look at the seizure phenotypes or like the seizure presentation in the mice. And so we can induce seizures, and we can also look at spontaneous seizures in the mice. And then we can also look at behavior and development. So for example, we can look at locomotor activity, social behavior, learning and memory. And then we can also use these mouse models to better understand sodium channel properties. So looking at the opening and closing of the sodium channels. And then we can also test potential treatments in our SCN8A mouse models.
Wow, that's definitely a lot. So what do you guys specifically do in your lab?
Yeah, so we actually study mice with different SCN8A mutations. So it's important to have mice with SCN8A mutations that can cause different clinical features. So looking at either the seizures and behavior. And so we were particularly interested in studying an SCN8A mutation that was associated with a range of behavioral challenges. Some of the other SCN8A mouse models out there have more severe seizures, but we were particularly interested in the behavioral challenges. And so this mutation, the arginine 1620 leucine or R1620L mutation, was identified in a patient with mild epilepsy and autism, ADHD, intellectual disability, and aggression. And so we wanted to make an SCN8A mouse model with this mutation. And so using genetic technology, we knocked in the R1620L mutation into the mouse SCN8A gene. And so we call these mice RL/plus or RL mutants.
That is so fascinating. So what did you learn from this?
Well, if you remember, I had said that we can look at seizures in these different mouse models. And so we actually found that the RL mutants are seizure susceptible and they have spontaneous seizures. So we performed EEGs. So just like in patients, We can look at cortical EEG, and then we can look at spontaneous seizures. And so here's an example of a spontaneous seizure that was found in our RL mutant. And as I mentioned earlier, we can also look at behavior in the mice. And we actually found that the RL mutants have a number of different behavioral abnormalities. So for example, the mutants are hyperactive, they have impaired sociability, they also have repetitive jumping, impaired social discrimination, and the mutants also have impaired object recognition.
Okay, that's very cool. So then how do you take what you found with these seizure and behavioral differences and turn that into something that could translate into humans?
Yeah, so we can actually use these mouse models to test drugs against the seizures and behavioral abnormalities. And so we can use these RL mutants and look at current anti-epileptic drugs. We could also test or repurpose drugs. We can also use FDA-approved drugs that are used in other epilepsies. And then we can also use the mutants to develop novel drugs. So here are some examples that some drugs that we've tested in the RL mutants and looked at the seizures or testability of these drugs against seizures. And so one current anti-epileptic drug that we were interested in is a sodium channel blocker, oxcarbazepine. And then we were also interested in repurposing a drug, huperzine A, which is a reversible acetylcholine esterase inhibitor that was previously used in patients with dementia and Alzheimer's disease. And so we first wanted to look at the effect of oxcarbazepine and huperzine A against induced seizures in the RL mutants. And so we score the seizure response on a modified Racine scale. So 0 means the mouse does not have a seizure, and then increasing in severity to a 3, where the mouse has a generalized tonic-clonic seizure. And so when we looked at oxcarbazepine, we tested vehicle and then increasing doses of the drug. So vehicle is the liquid or solution that the drug is made up in, but without any drug. So it doesn't have any effect on the mouse. And so when we look at the seizure score for vehicle treated mutants, we found that all the mice had a seizure. And then when increasing doses of oxcarbazepine, we found that at our highest doses that we tested, 50 mg per kg oxcarbazepine, we found that all of the RL mutants were protected against an induced seizure. And the same was observed with huperzine A. So we can see all the mutants that received vehicle had a seizure, and that all of the mice that received 1 mg per kg hupe A were completely protected against an induced seizure. And then we were also interested in testing cannabidiol or CBD. So CBD is actually an FDA-approved drug for other severe pediatric forms of epilepsy. And so we were interested to see whether CBD would be protective in our RL mutants. So again, we induced a seizure. And remember, the 0 means that the mouse does not have a seizure, and then increasing in severity to a 3, where the mouse has a generalized tonic-clonic seizure. And so we tested vehicle-treated mutants and found that they all had a seizure. And then we tested increasing doses of CBD, and we found that at our highest dose tested, 360 mg per kg CBD, most of the mice were protected against an induced seizure. And as I mentioned earlier, we could also look at the effect of drugs on behavior. And so we were interested in testing whether CBD could also improve behavior in the RL mutants. And one feature that we found earlier was that our RL mutants have abnormal social behavior. And so when we test social behavior, we use a 3-chamber apparatus. And so in this experiment, there's the test or experimental mouse here. And the experimental mouse is given the option to explore a familiar mouse, which is a mouse that the test mouse has seen or interacted with before, or explore, the experimental mouse gets to explore a novel mouse, which is a stranger mouse. And so for a normal wild type mouse, for the normal response is that since the mice are naturally curious creatures, they prefer and spend more time with a novel mouse compared to a familiar mouse. And so when we looked at our RL mutants, we found that with following vehicle treatment, the RL mutants spent similar lengths of time exploring the novel mouse and familiar mouse, demonstrating that the RL mutants have a deficit in social behavior. However, after CBD treatment, we see that the RL mutants spent more time exploring the novel mouse compared to the familiar mouse, demonstrating that CBD could improve social behavior.
Wow, those are some amazing results. You make doing mouse research seem so easy, but we know it takes a long time. So, in your opinion, why does this work take so long?
Good question. It definitely takes a while to do mouse research. So the first reason is that it takes time to generate and validate a mouse model. For example, if a mutation is more severe, it may take longer to establish the mouse line, and so it takes a little while to make a mouse model. But we also need time to generate enough mice for experiments. So if we're looking at seizures and behavior, we need a lot of mice. And thirdly, we need to ensure that our results are done rigorously and are reproducible. And finally, our findings must be peer reviewed. And so it's important to publish our findings so that we can share our results with the community.
Okay, I see that there definitely seems to be a lot that goes on behind the scenes to make research like this happen. So then, what are the challenges of turning great work like this into something doctors can use while treating patients with SCN8A?
Yeah, so there's definitely several challenges. So first of all, mouse models can be important to identify potentially beneficial drugs, but this is just the beginning. Um, and so I've shown you some examples of seizure and behavior data, but to look at the effect of drugs on spontaneous seizures and behavior are quite time consuming. And it's also important to examine long-term effects of drug administration. So patients with epilepsy will often have to take treatment or have treatments for long-term. So it's important to understand the long-term effects of a drug. And as you know, not all patients respond to treatments in the same way. And so it's important to test drugs in more than one mouse model. And finally, it's important to remember that mice are not small humans. And so while we can find a drug that might be really beneficial in mice, it may not translate to humans as well, or vice versa, where a drug that may not be as beneficial in mouse may be really good in humans. But it's important to better understand all of this, and using mouse models is definitely the first way to identify potential treatments that might be beneficial in patients.
Well, thank you so much for your time, Jen. It looks like you've done a lot of great work, and I know I've learned a lot about mouse models. To the rest of you, thank you for joining us for SCN8A Unraveled, where we unravel the science of SCN8A.